Okay, so today we're looking at probability statements. For probability, we do a lot of reducing fractions. So just to review real quickly, Mr. Sager, unplug the statement. So again, you need to be sure you're doing this with your calculator and just not watching me do it so you get the practice that you need. Okay. When you have a fraction such as 4 over 12, you got to reduce it to lowest terms. So you divide, if you have two even numbers, you can always divide by 2. And so that equals 2 over 6. And again, use your calculator if you need to, right? Like simply on your calculator, go 4 divided by 2. But before that, you should have an idea what the answer is. So 12 divided by 2, I think is 6. Let me double check. Do it on my calculator. Yes, it is. Now you got some learning happening. Guess and check. Don't just use your calculator, but try and guess and check. Okay? It's not in lowest terms because anytime you have two even numbers, you can always divide by 2. So I can reduce one more time. Divide by 2, divide by 2. And the proper work is to show it twice. And I get 1 over 3. Okay? Sometimes it's a little harder. Maybe you have like 15 over 21. So you're going to guess. You're going to try dividing by 2. And you're going to go 15 divided by 2 won't work. Not just because I tried it, but because I know it's an odd number. Only even numbers work for dividing by 2. So what's the next number higher than 2? 3. So check out 3. 15 divided by 3, I think, is 5. Yes, it is. Now, what about the bottom? Can I divide that by 3? Well, I think it's 7 divided by 3. Yes, it is. So you'd write this down, equals 5 over 7. And that's in lowest terms, okay? Because I know I can't divide 7 by 5, all right? And they're not divisible by 3. So you will have to reduce fractions to lowest terms. You also have to take your fractions, turn them into decimals, and then percents. Like I've done about 3 minutes of notes, and you're just now taking out your booklets, even though everyone else has had their booklet out while we're waiting for Nick to get my computer. That's what I'm talking about, right? Focus faster. And then you're disturbing others by laughing and giggling. Probability statements. Probability tells us how likely it is for an event to occur. Okay? It doesn't tell us exactly what will happen, but it's just a prediction. Prediction is the key there. It's not set in stone, it just tells us how likely an event will happen. So looking at coin flipping, we look at coins. Okay, we look at coins, we look at dice, we look at cards, and we also, for this unit, we look at spinners. Each spinner will be a little bit different. So that's where you spin an item, right? You spin a top and it points, the arrow points at different colors or different numbers. So when you flip a coin has how many sides? 2. There are 2 choices on that coin. One can be a head or one can be a tail. Now the tail can be, of course, different things. So flipping a coin is usually based off the nickel because we have a head and then the beaver tail on the back side. Or penny, when we had the penny, it was a head on one side, maple leaf on the other. The dime, head and a sailboat, right? The Blue Nose schooner on the back of the dime. What's on the quarter? Caribou. Squirrel? Dude, have you not listened to Raffi? I think Raffi has that song, right? No? Yeah, exactly. Yeah, that's the nickel. Okay, what's back on the loonie, Ben? A loonie. It's a loon, man. Oh my gosh, you're killing me. So the probability is expressed as that. First of all, you have the event in brackets. This will change depending on what we're trying to find. So that could be a red, it could be a 9, it could be a 4, whatever. That changes all the time. And then on top will be the number of favorable outcomes. So as a fraction, that number goes on top. On the bottom of the fraction, you have the number of possible outcomes. So when you're flipping a coin, how many heads are on the coin? 1. So 1 is the favorable outcome. It goes on top. How many possible outcomes are there when you flip a coin? How many sides? 2. Okay. So that's the fraction form. So the fraction is 1 over 2. You can turn that to a decimal by going 1 divided by 2. 1 divided by 2 equals 0.5. That's the decimal form. Then to go from decimal to percentage, we times by 100. That equals 50%. So there's the 3 forms. We have the fraction, lowest terms, we have the decimal, and we have the percentage. You could be asked for all 3 or for a certain one, but you want to find in that order. The fraction, the decimal, the percent. Fraction, decimal, percent. Now, is that different when you're trying to find the probability for flipping a coin and getting tails? No. There's only 1 tails on the dice. There's 2 possible outcomes. So the fraction's 1 over 2, the decimal is 0.5, and the percentage is 50%. Okay. Now let's see how well this works. Let's pull up a coin flipper here from the internet. I don't know if you've heard of that, internet. Okay. And so you'll go coin flipper. Boom, this one works good. We'll do this. All right. So anytime I flip the coin, you want to mark down the result, and we're going to see if we get 50-50. Okay. Whoops. There we go. Okay, you guys ready? All right, so flip. Heads. So you want to put one line there. Okay. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3. You guys understand? Okay. Scratch, scratch, scratch. Okay, so 1 heads. Okay, so here we go. Mark this down. Tails. 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 Okay, so she have 5 marked down. Heads. 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 Tails. Heads. Is that 10? I think that's 10 now, isn't it? Okay, so how many heads do we have now? 4? Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Right. So not 50-50, but the more we do it, the more chance we have of getting 50-50. So let's do 10 more. Heads. Oh, you guys have 5 and 5? Someone said they had 6 and 4. 6 and 4. 6 and 4. Well, now it's what? Now it's oh, how come you guys can't see? Oh. Was I writing notes and you guys couldn't see? Oh, it just turned off. Okay. I'll just wait. Okay. Here we go. Heads. Yeah, but I'm saying it, so write it down. Heads. Tails. Heads. Heads. Tails. 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 I think that's 20. What do you guys got? Oh. You have 17? How many you guys got? You got 18? Okay, Logan, let's go with yours. How many heads do you have? Okay, so 8 heads, 10 tails. Please change it so everyone has the same. 8 heads, 10 tails. 8 heads, 10 tails. Fix yours. 8 heads, 10 tails. You guys ready to continue? This is way closer than this morning. This morning we had way more tails. Oh, wait, 10 more. Tails. Heads. 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 Tails. Tails. Heads. Tails. Heads. Heads. Heads again. Okay, what do you guys got? 15 heads, 14 tails? Okay. So that's super close. And 14 tails. 1, 2, 3, 4. Okay, one last set here. Last set. Okay, ready? Flip. Tails. Tails. Heads. Tails. Heads. Heads. Tails. Heads. Heads. Tails. Heads. Okay, what do you guys got? Oh. 21 heads, 19 tails. 5. There you go. Okay, so 21, 19. That's pretty darn close, isn't it? This morning wasn't nearly this close. The idea is you're not going to get 50-50. You're going to get close to it, which we are. And the more you do this, the closer you'll get percentage-wise. The reason why is because it's not telling you exactly what you're going to get. It's just predicting your chances of getting these events, right? It's just a prediction. So keep that in mind when you're gambling using your probabilities. You're predicting. You don't know what's going to happen. Play the chances, but you don't know. And that's why people lose money constantly. In the casinos, all the probability is in the favor of the casinos. That's why people lose money all the time, right? You're giving them your money because the probability is in their favor. So don't gamble. There you go. Exactly. Okay, so going on then, standard deck of cards. We'll work on some more probability questions. Standard deck of cards. What's all in a deck of cards? There are 4 suits. Okay. There are what? Hearts. Hearts, which are red. There are diamonds, which are also red. Clovers. Okay, these are also red. Oh my gosh, you guys don't know what a deck of cards looks like. Then we have spades. Okay. Spades look like kind of an upside down shovel. Oh, that's bad. Oh, that's really bad. That was. That's better. There we go. Spades. Then you have clubs. Clubs. Yeah, clovers or Okay, there's your clubs. These ones are both black colors. Okay. Then you have your ace, which is sometimes low as a 1, sometimes high as a 13. Then you have, what do you have? 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all your number cards. Then you have Jack, Queen, King. What do we call these ones? Face cards. Okay. And there's actually different names for them, right? Like, well, I'm not going to go into that. What's that? Jokers don't count in a standard deck of cards. Okay, there's 52. There's 4 different suits, right? There are 13 cards of each. So there are 13 hearts, 13 diamonds, 13 spades, 13 clubs. And that's how you get the 52. Okay. So looking at probability, what is the probability of a spade? So you start by writing down P, then you put brackets, then spade, S-P-A-D-E, in case you know how to spell it, bracket, equals. So how many spades are there in a deck? I just told you it's written down. 13. That's how many favorable outcomes there are, because there's 13 spades. And how many total cards are in a deck of 52? Glad you're listening. So now we can divide it. Well, you can't divide 13 by a lot of numbers. What's the only number you can divide 13 by? 13. It's a prime number, one in itself. So let's take 52. Can you divide that by 13? Oh, gosh. Yes, you can. So you can divide them both by 13. Divide by 13, divide by 13, and you get 1 over 4, which is a quarter. Okay. Then you can divide it. 1 divided by 4. What is that as a fraction? Sorry, decimal. 0.25. Then you can go times 100, and you get 25%. Okay. Yes, Logan. Well, won't you get a wrong answer then? It's a different fraction, so won't that give you a different decimal? 100. You sure about that? Is it this number you're talking about, Chase? Okay, so Logan's saying 13 divided by 52 will give you the right decimal. I don't believe him, so I'm going to use my calculator. And the funny part is, you guys actually think I didn't know that. 0.25 times by 100, guess what? You still get the exact same answers. Okay. Problem is, if I want the fraction form, you have to make sure it's in lowest terms. Okay. But if they say what's the decimal or what's the percentage, yeah, man, 13 divided by 52, less writing. Whew, that'll save your fingers. Okay. Any questions? Okay, moving on. What's the probability of getting a 4? So you write down P bracket 4 bracket equals. And we all know there's 52 cards in a deck, so we'll keep that as the bottom number. But how many 4s are there in a deck of cards? Really? Because there's a 4 of spades, a 4 of hearts, 4 of clubs, and a 4 of diamonds. You're right, there's 4. Okay? So what is that as a decimal? Use your calculator. What is that as a percent? Use your calculator. Let's go, do your math. Don't just let me do it. Do your math. 4 divided by 52. Do your math. So 0.0769. And we'll just go 0.076. 4 divided by 52. What's that? You went, no, you must have been multiply by accident. Try it again. 4 divided by 52. Times by 100, turn into a percentage. 7.69%, so 7.7%. Okay. What's the probability of a red card? Quit calling out, man. What's over 52? How many red cards are there in a deck? Add them up. You sure about that? 13 plus 13, 26. Good job. Okay. Let's just leave this as a fraction. Put it in lowest terms, please. Leave this as a fraction, put it in lowest terms. So I know you can divide them both by 2. 13 over 26. What can you divide them both by? Yeah, if you start at the beginning, you can divide them both by 26. If you didn't get that, 1 over 2, half. Okay. Can you guys look at half and tell me what the percentage would be? 50%. Yeah, totally, right? Good job, guys. Good math skills. What about the face card? This one's a little bit weird now. Okay, so probability of a face card. So face goes in brackets. Okay, 52 cards in a deck. That goes on the bottom again. How many face cards are there? Well, each deck has how many? Sorry, each suit. Does ace have a face on it? Oh, that's how many cards you got. Let's go images. Face card. Boom! Did you see a face? Nada. Okay, so no face cards. So you only have, each suit has 3. Okay, so it's 3 for the hearts, 3 for the diamonds, 3 for the clubs, 3 for the spades. How many total? 3 times 4 is 12. 12. Okay, so divide by 2, put in lowest terms. Go. Put in lowest terms. Divide by 2, divide by 2. Oh, looks like you could divide by 2 again. So divide by 2, divide by 2. What'd you get, Animal? 3 over 13? Okay, so 3 over 13. Any questions? Can you go to a decimal and a fraction? Yes, you can, but we won't do that anymore. Let's go to this next one here. Probability bracket 2 or 4 bracket equals 52 cards in a deck. Yes, Logan, question? Okay, so how many 2s or 4s are there? I think you're confusing spades and suits. Right? So 4, right? 2 of hearts, 2 of diamonds, 2 of clubs, 2 of spades. There's 4 2s. 4 of hearts, diamonds, clubs, spades. How many altogether? 8. Okay. Why are you guys laughing at that? It's like silly, immature little noise. Come on. Okay. Divide by 2. Put in lowest terms. Go. 4 over what? 26. Okay. Let's go to a decimal. Okay. 4 divided by 26. Go to a decimal. 0.153. Times it by 100. What the heck was that? Is that from the back? 15.3%. Okay. Yeah, you can. I think 1 out of, no, 2 or 13. Yeah. Sorry, I just wanted to get going here. All right, next one. looking at a dice. So for a dice, there's 6 sides. You have a 1, a 2, a 3, a 4, a 5, a 6. So what's the probability of rolling a 6? Probability of 6 equals, there's only 1 on the dice, so it would be 1 over 6. Okay. What's the probability of rolling a 7? How many 7s are on a dice? 0. So there's 0 chance of rolling a 7, you ding dongs. Well, then they would be specifically showing you something else. We're talking about a standard Monopoly dice. Meatheads of meatheads. Okay, what's the probability of less than 7? So I'm using my less than symbol here. How many numbers on the dice are less than 7? Oh my gosh, they're all less than 7. So this equals 100%. What's the probability of rolling a 2 or a 4? How many 2s are on the dice? How many 4s are on the dice? Why do I have this feeling you're not copying your notes down, Benson? Then what's the fraction, Benson? You just told me there's 1 2 and 1 4. So you have 2 favorable outcomes, Benson. What is that in lowest terms now? Reduce it to lowest terms. 1 over 3. Okay. What's the probability of being odd? With Benson, that's 100%. What about our dice? That's why I like you, Chase. You're listening. Okay, so it's a 1, a 3, and a 5. How many favorable outcomes? 3. Lowest terms? 1 over 2. Okay. Okay, almost done here. Now you have a bag of marbles. This is another classic one, the marbles. Okay, so we have 6 blue, 3 red, 4 yellow, 7 green. What's the probability of green? So we have 7 greens over what? How many total marbles do we have? You guys pay attention. 20. So the probability is 7 over 20 for a green marble. What's the probability for a red marble? Still 20 marbles. 3. So the probability is 3 over 20. Of course, you could turn that to a decimal and to a percentage. Okay. Usually, we like to keep it as a fraction. Y or R, yellow or red. 3 reds, 4 yellows. That's right. There's 7 possible positive outcomes over 20 because there's still 20 marbles altogether. Here's a tricky one. Probability of a yellow, red, blue. Peyton says 13 over 20. Is she correct? So add them up. Okay? 3 plus 4 plus 7. 14. That's okay. 14 over 20. I thought it was right. I was actually going to write it down. So I didn't even look at it. Okay. You guys are pretty good with probability. So here's how we use it to make some predictions. Okay. What we have here is we have a sample. We've got a bag of marbles. For the sample, you pull 6 marbles. Change that word to marbles. Okay. And 5 are red. 1 is blue. So from your sample, what's the probability of pulling a red marble? Well, 5 over 6 that you pulled. So 5 over 6. Yep. What? Oh, I used 7 green ones. You're so right. Well done, Peyton. Well done. 13. Way to correct the teacher. Woo! You should be up here. What's that? Yeah, it's 5 over 6 because you're not worried about the 80 marbles, right? You only pull out 6. You take a sample of all the marbles in that bag. And the probability from this sample was 5 out of 6 red marbles. So what you can then do is you can use that to make a prediction. So what you're going to do is you're going to take your probability and times it by the amount that you have. So our probability is 5 over 6, and we're going to times that by 80 marbles, because there's 80 marbles in that bag. So whenever we're doing this on our calculator, it's been a while since we did our conversion factors. That is like 5 times 80 divided by 6. Okay, so 5 times 80, then divide by 6. So go ahead, use your calculator. 5 times 80 divided by 6. Go. 5 times 80 divided by 6. What'd you get? Wow, that's weird. So what do you think we should round up to? Because you got to have whole marbles. Round up to 17, you're right. Okay. So 17 reds. Now, what is the probability of blue? 16.666. It's really close to 17, so we round up. Oh, whoops. Oh my gosh, 66. Chase, well done. You and Peyton all-stars today. So it'll be 67 because it was 66.66. There you go. Okay, going back to blue now. Probability of blue, what is it? What do you think? You tell me. What's the probability from our sample? How many marbles did we pull out in our sample? So that goes on the bottom. How many of them were blue? 1. So for our prediction then, our probability times 80 will be 1 over 6 times 80. Okay. So what is that? 13.333. What should we round to? There's got to be a whole number for marbles. 13. Okay. Now, you have 80 marbles. Guess what? 13 plus 67 must equal 80 because you have to have 80 total. Okay. So we could have, once we found one of them, once we found 67, we could have subtracted 80 minus 67 because the leftover would have to be the 13 blue. So there is more than one way to do that. Keep that in mind. Your homework is to finish the rest of the booklet. So you're doing probability. Some stuff, they'll lead you through it. Others, right, they're going to lead you through it, so you fill in the blanks. So keep that in mind. Okay. Then you're doing your spinners, your cards, marbles, and then a few more applications. Don't forget you got your skill builders, your dice, and your spinner at the bottom. This is what a spinner looks like. Okay. Example of a spinner. Any questions? Oh, you're working. Go.